Okay, so with runtime polymorphism, you have to understand that we can make some changes in the code so that when a user makes a change, then the execution will alter itself in the runtime portion while the code is running. Now, it doesn't seem like that while we're programming it sometimes. It isn't as obvious as it might seem, but it does do that. And so we start off with the idea of abstraction. Now, technically speaking, abstraction in and of itself doesn't really mean that it is polymorphic. However, the way that we're going to talk about it here makes it polymorphic because we are using inheritance and we are inheriting from an abstract class. Now, an abstract class is a really kind of unique concept in as much as you can set up sort of a template, if you will, that you really can't change when you inherit. You inherit and you can override, but you can't instantiate an abstract class. The template of the abstract class is the sort of thing that is what it is, and the only way to make changes to it is through inheriting from it and then doing an override. So when we're talking about this, we are inherently setting up a abstract class in this particular scenario. We are setting up one, and I'm calling it shape, and it has one method, which in this case is called area, and it is also abstract. Okay, so we have an abstract method, and what we mean by that is it really has no body. It is just an idea that we can use then to flesh out in something that then overrides this template for a polymorphic in a polymorphic fashion. Now, in this particular instance, the shape that we chose to use in the handout was rectangle, which is fine. In this particular thing, you can see that rectangle inherits from shape, and within rectangle, it has a method called area, which returns width and length, which is within the class. Okay, so there's a private variable length, a private variable width. This is a little bit overdone in some respects. Rectangle has a constructor which brings in length and width from the calling instantiation, and then transfers those values to private variables, and then those variables are used to return the values. Now, this is good programming, don't misunderstand, but it does obfuscate a little bit why we're doing it this particular way. So let me go back to the main form here, and this is the abstract one here. I call it dyna-abst because I got tired of typing long titles. Okay, so we instantiate rectangle, and I create a variable named r which holds the instantiation, and I'm passing in 10 and 7. Okay, so when I go back to here, 10 and 7 come in when this is instantiated, and they are immediately set to length is 10, width is 7. So when we then go back here and we say r dot area, it returns the value from rectangle, which says width times length. Okay. So it does this, and again I'm putting toString on the end of it because I'm putting it into a text box called abstract textbox.text, and on the form it looks like this. There's a text box here, so that when I click the button, as soon as I click the button, it instantiates the rectangle, passes in the values of 10 and 7, and then gets those values back out and puts them into the text box that's here. Okay, so I want to run this. 10 times 7 should be pretty clear. When I click this, I get the value of 70. Okay, so this is really fairly clear. Now, I ended up having to, because this is an abstract, because this is an example of an abstract being used as polymorphic, you end up having to have two or more. You have to have two. You have to have two classes. Okay, you have to have shape, which is here, which only has the abstract, and again this cannot be instantiated. And you have to have rectangle, which is inheriting from shape, and then you need to override area. And this is just for the demonstration purpose. We're overriding area from shape. Now this has two components, and theoretically we could also make another class called triangle and use the formula for the triangle and return it, and it would be the same type of thing. Okay, so if we were to do that, we would go into here and we'd instantiate a triangle, and we'd pass in the two values for the volume of a triangle, the area rather of a triangle, and then we would call area and it would work for that. Okay. Note that triangle would not inherit from rectangle. Triangle would inherit from shape. Now it's important to note that we could simply make a item like this without an override. We could simply make a rectangle with a method called area and bypass the abstract class altogether, but it wouldn't be polymorphism there, it would be simple inheritance. Okay, so the only reason this is quote-unquote polymorphic in this particular case is because we are inheriting from the abstract class. Now there are reasons for doing this in certain cases. One of those is that, like I said, you could create a triangle which also inherits from shape, or you could create other things which you can find area based upon the same concept of pulling in an item and passing in the necessary values. They don't even have to be two values. It could be three values or whatever it takes to generate area. This would override it, and it would always be called, from a polymorphic standpoint, it would always be called area. So when we did this, it would always be, whatever variable we're using for whatever type of thing, it would always be called area. there is a discussion that says that polymorphism is not necessarily a good thing, in as much that it does obfuscate whether or not you are using a method that is just directly created, or whether you are using something like abstraction or a virtual method, which we'll discuss in the next video, and are hiding aspects of the programming for, not necessarily the right reasons. And when you are doing runtime polymorphism, it can slow your program down noticeably. So, this is more for your knowing what it's about than it is to say, oh, we should use this because this exists. Okay, so be aware of that. Okay, so one more video, and then I'm going to put my foot back up again.